Now let me solve the problem 3. As we know that x of t is a white-stand stationary process, and then we know that the expected value of x of t it is equal to a constant which is not dependent on t, and the autocorrelation x Rx of t1 and t2 only equals to the Rx of tau, which tau is equal to t1 minus t2. And then y of t is the output of the system, so that y of t it is equal to the convolution of x of t and h of t. And then the expected value of y of t it is equal to the expected value of the convolution of x of t and h of t. And we take the expected value inside, which is only due at the x of t. And this is equal to the expected value of x of t and convolute with h of t. And it is equal to the expected value of x and multiply the integration of h of alpha from minus infinity to infinity. This is also a constant which is not dependent on t. So the expected value of y of t is not dependent on t. And then we will find the autocorrelation of y. And firstly, we find the cross correlation of xy, Rxy of t1 and t2. It is equal to the Rx of t1 and t2. And the correlation the convolution of Rx of t1 and t2 with h of t2. And this is equal to this integration of Rx of t1 and t2 minus alpha and multiply h of alpha d alpha. So this is finally equal to the Rx of tau plus alpha multiply alpha and then the integration, so that we know that Rxy of tau equal to Rx of tau, and the convolution of Rx of tau and h of minus tau, and similar as the first one. And then we find that the autocorrelation of y of tau equal to the cross correlation of x and y of tau and convolute with h of tau, so that finally we know that the ryy of tau it is equal to the Rx of tau, and then convolute with h of minus tau and convolute with h of tau, so that we know that this ryy of tau it only depends on the value of tau. So that from above we know that expected value is a constant. Expected value of y of t is a constant. It does not depend on t, and the autocorrelation of the y of tau it is only dependent on tau. So that from these two we know that y of t is also a white-stand stationary. That's all the explanation of the problem 3.